So I will now continue with the first presentation of today, and I did want to take a moment to flag the logos of our ICAM members at the bottom of the slide. ICAM is a coalition, and it is by learning from each other on all those amazing partner organisations and grantees that our members work with that we're able to pull together learnings about population management of cats and dogs. And hence the guidance and tools that we have been able to produce have only been made possible because of these members. They are our only funders, and they are indeed our composite brain. I also want to give credit to John Fryer of the Wise Monkey Foundation. John is the developer and the ICAM partner in the creation of Talea, and it was thanks to his many years of supporting people to collect data, store data, and use it to advance their learning that ensured that Talea became the simple but also flexible tool that it is today. So our ICAM mission is to support the development and use of humane and effective companion animal population management worldwide. And if you have read our guide to DPM, you will have also seen our DPM principles, which includes the principle that you need an evidence base to design and evaluate with wisdom on your side. So in 2015, we launched Are We Making a Difference? A guide to monitoring and evaluating dog population management interventions. We saw a rise in interest in monitoring and evaluation and some indications that more data was being collected, but we heard people found it difficult to move from a place of ambition to actual monitoring action. One barrier was the lack of easy to use tools for data collection, and one method of measurement covered in the guide that received particular interest was street surveys. Now, that's not to say that street surveys are the only method that you need for measuring the impact of your intervention. This is a list of all the impacts and indicators we cover in our Are We Making a Difference guide. And in the final column, we see suggested methods for measuring those indicators. We see street surveys crop up several times. They are useful, providing a way to measure several different indicators that can reflect change in 3 important impacts. But I think they're also an attractive option because compared to some methods like household questionnaires, they can be relatively cheap to implement. Now, you can really go to town with street surveys and conduct detailed marked resite approaches across vast areas, but you don't have to. And in our ICAM guidance, we suggest some pretty simple approaches to street surveys that allow you to use indicator counts or index counts to track changes in the dog population over time, methods that can also be used for cats. Street surveys are also attractive because, unlike secondary sources of information, you can implement this data collection yourself, so you have some control. But it's right to point out they're not sufficient on their own and should be used alongside other methods to achieve a data set that allows you to have real insight into the dog and cat populations and how interventions may be changing them. So I'm assuming here that you've decided to invest in street surveys, and now we're on to the question of how do you actually implement them. So what makes Talea a potentially attractive option to you? Now, I know there are other apps available, and if you've come across a solution that's working for you, then that is great. Don't swap unless one of the following characteristics provides you an added benefit. So, starting with the structure of Talea. It is comprised of Talea Web, which is the website portal where your survey manager sets up surveys, invites observers, and sends out survey packages. Importantly, this is also where you can see the data that's being collected. And then we have Talea app, and this is what your team of observers have on their phones and use to navigate along their survey route or within their survey area, and also to record any animals that they see. The most important characteristic of Talea Web is its flexibility. So templates are the questions and choices you will present to your observers when they are out on the street and they see an animal they want to record. There is a library of templates that you can use, or you can amend these or create your own from scratch. So although the library of templates are designed with dog and cat surveys in mind, you can use Talea for any animal. In fact, for any sighting. You could take Talea out onto the street and count red cars if you like. Sandboxes are where your observers will do the survey, and you can give them routes to follow or present them with polygons or areas within which they do the surveying. Sandboxes can be set up to record the GPS location of the observer when the sighting is made. This is usually precise enough for dogs and is the default setting. But you can, if you like, require your observers to tap on the map to show the precise location of the animal when it's seen. This might be more relevant for cats, or if you're using distance sampling in your analysis, an approach that is commonly used for wild mammals and birds. The one limitation of Talea Web is that it's in English, so your survey manager needs to be comfortable working in the English language. When it came to the app, our primary goal was to make it easy to use. So once you add an animal sighting, you answer questions about that animal, and the answers are represented with icons, not just text, and you select with a single tap. You can edit or delete any sighting, and the app provides you with navigation around the sandbox, showing you where you have been with a green track, which turns red if you stray too far from the sandbox. It also shows the locations of all the animals you've recorded so far. Importantly, Talea app can be used in any language. The survey manager is responsible for making sure the correct translations are included in the template in Talea Web. The main limitation with Talea app is that it's only available for Android devices. It doesn't work on iPhones. Now, we'd really like to change this, so we're currently looking for funding for this next stage of development. I'd now like to give you a very brief summary of how to get yourself set up on Talea. The very first step is to create your own Talea project by using this sign-up page. You will then receive an email from admin@wisemonkeyfoundation.org with a link to another web page where you create your own password. This will automatically create your Talea project. Your username will be your email. The link to this sign-up page is on the Talea user guide webpage. Please take note that this user guide exists. I'll make sure the link to the user guide is posted alongside the webinar videos after this event. This user guide has both written instructions and videos for all the processes and functions of Talea, so it should walk you through everything you need to use Talea. If you need extra support or you want to let us know that something is missing from the guide, please email us on talea@icamcoalition.org. Once you've completed the sign-up, you can log into your Talea project via the Wise Monkey portal using your email and password. And this is what the Talea dashboard looks like. I'll now give you a quick tour of the functions. First, we have locales. Open this and you'll be able to select additional languages for your Talea app users. English will be ticked as default, and you can tick as many additional languages as you need. Different observers within the same project can be using Talea app in whichever language they prefer. If you want to use a language that's not listed here, please email us at talea@icamcoalition.org and we'll add that language for you. The next function is templates. These are the questions and choices presented to observers when they record an animal. As I mentioned previously, you can pull a template off the library shelf, which you can use as is, or you can amend it further, or you can create a template from scratch. Notice that the question and each of these choices has English in this box and then space for a translation that has been added here in Spanish. This is what any observers will see if their locale has been set to Spanish. If the box is left empty, they will see the English default instead. This is Sandboxes, where you can create either routes or polygons by uploading a KML file. This is what your observers will see when they're surveying, plus their own location and the track they have taken since they started the survey. Your observers need to be put into groups. You may only have one group if you are focused on a specific area and have just one team of observers, but some organisations may need surveys done in more than one location and have more than one team of observers. You don't want to confuse the Cambridge team by sending them surveys or packages that must be completed in London. So groups help to keep everything clear for your observers. Once you have your templates, sandboxes and groups, you are ready to invite your observers to Talea app. Enter their name and their phone number here, including the country code. And once you click save, they will receive an SMS to their phone. The first link in the SMS takes them to the Google Play Store where they install Talea app. Then they go back to the SMS and tap the second link. This automatically opens up Talea app and enters the invitation code to your Talea project. They then enter their name and then register. They then should be all set up to receive survey packages from your Talea project. Here we have studies, a relatively simple form where you describe a study name and which template that study will use. Projects can hold any number of studies, which are each associated with a particular template. Studies often describe a place, such as a town or city, and the animal you will be surveying, such as a Bangkok dog survey. Think of studies from the perspective of later analysis. If you wanted to combine or compare the data from surveys, you would want all the survey data in one Excel file. So make sure all these related surveys that use the same template fall within one study. Surveys that are fundamentally different, for example, a dog survey in Bangkok versus a cat survey in Bangkok, will use different templates and will exist as different studies. So now you can use packages to send the survey information to your observers. You enter the package name, state which study this package will be part of, and therefore which template it uses, and then also where the survey should be done by picking a sandbox. Finally, you tick which groups of observers should be receiving this package. When you create a package, you are creating a request for a survey to be done. You are packaging up a template and a sandbox and sending it to your observers, and off they go. Once they have completed the survey, they sync their app and the data immediately appears back in your Talea project. It's important to note that the observers do not need internet access during the actual survey. Talea app will work offline. The final function I want to show you here is analysis. When you open it up, you can see the data is nested by study, then sandbox, and then the individual surveys. If you click on an individual survey, you can see all the details about that survey, when it took place, for how long. You can see the animals they recorded, the route they were following, the track that they actually took. Importantly, this is also where you can download your data in 4 different data formats so that you can work with this data using other software. So that completes my high-speed run through the basics of how Talea works. I know this won't have been sufficient as a how-to guide, so please do go to the user guide webpage to understand how to use each of these functions properly. I did want to spend a bit of time talking about what to record. Now, this obviously depends on your impacts and indicators, what would actually matter to you and your intervention. So if your desired impact was to reduce the number of roaming dogs or cats, a potential indicator would be the number of dogs or cats per kilometre of street surveyed. Therefore, your observers would be asked to record every unconfined and unsupervised animal within the sandbox. If you are aiming to reduce breeding of roaming animals, you may be looking at the indicator of the percentage of roaming females that are lactating, or the percentage of all sightings that are puppies or kittens. To measure those indicators, your template would ask observers to categorize every sighting into types. It's important, if you are including these types within one question, that these types are mutually exclusive. So any one animal can only be one of these types, and there are no missing types. So you aren't going to see an animal that doesn't fit into one of these. Now you could arrange these as a number of subsequent questions. So start with age, then sex, then sterilization status, and then lactation, noting that you can use skip logic in Talea. So only when the sighting is of an adult female that's unsterilized will the observer be asked whether they're lactating. However, this approach does take more time than answering a single question. And when you have a lot of animals and busy observers, you want to do whatever you can to make the survey as quick as possible to conduct. If you're looking to have an impact on animal welfare, then you might look at indicators like the percentage of adults in poor body condition, in which case your template would include a question that asks for all adults to be given a body condition score. Similarly, you might want to measure the percentage of adults with a visible skin problem. With all these attributes or characteristics, it really matters that you have good inter-observer reliability. That means all your observers score animals in the same way, and also good intra-observer reliability, which means the same observer scores in the same way over time. And to achieve that, you need to invest in observer training and refresher training. For example, ICAM has developed a body condition scoring quiz that you can access on our website and test your observers. Although I will say that testing people with real animals on seen on test or pilot surveys will also be necessary. In general, when you're choosing attributes, try to keep them as simple as possible. So you notice I talked about the body condition of adults. You could score puppies as well, but actually you need a different scoring system for puppies, and they tend to be less visible when surveying. So use the more accessible adults as your index for population health. Similarly, with skin condition, you can have scoring systems for the severity of skin problems, but only use these if you really need to. Keeping it simple means your observer reliability is likely to be higher, and therefore your data will be more reliable. Also check that your attributes really matter. Is the data they will produce really necessary? You could include coat length or the size of dogs or cats, but do you really care in the long term whether this changes? Is your intervention likely to change such things? Remember, every question adds time to your survey, so just stick to what really matters to you. Finally, if your intervention provides marks that will be visible to the observers, you are also likely to want to record something that measures your intervention coverage. So this can be captured in your template as part of the first question about the type of dog, which includes categories for sterilized males and sterilized females. Or in this cat TNR example, which Joe will be talking about more in a moment, the first question asked whether the cat was ear-tipped or not. And in this example, we have a very simple template for running a vaccination coverage survey, where the only question was whether the dog was marked as vaccinated or not. I'd now like to talk you through the issue of where to survey. Now, some projects will be focused on relatively small areas that can be surveyed completely, in which case you can run a census survey, and your sandbox describes the entire project area within a polygon. However, for many of us, the project area will be too large to cover in its entirety, and in which case we're looking at surveying in a sample and extrapolating to the wider project area. Now, sampling is quite a broad subject and not something I can cover completely today by any stretch. However, I can recommend the Introduction to Sampling written by the DC Cat Count team as a great read if you want to get a more detailed overview. I've included the link here to their hub. This is where you can find this particular sampling guidance, but plus many other useful parts of their cat counting toolkit. But let's look now at some commonly used options for sampling in dog and cat surveys. First, at polygons. You can select a sample from the smallest available administrative units. For example, here is an image of the wards of Dhaka in Bangladesh. from which you could feasibly pull a sample for surveying. That could be a random sample where every polygon has equal chance of being selected, or you can stratify the sample in some way. For example, ensuring you get a sample of polygons that represent inner city, suburbs, and industrial areas. You can create your own set of polygons from which to draw a sample. Here is the example from the DC cat count, with DC split into 1,220 equally sized squares, from which they drew 220 squares, or 18% for their sample. And here is an image of Cairo, which was split into a grid of blocks using major roads, with each block containing approximately 5 kilometers of street, from which 1/4 were randomly selected as the sample for surveying. An alternative to polygons is using routes, which has tended to be my approach when surveying roaming dogs. Routes are also known as transects. They work well in urban or semi-urban environments where cats and especially dogs tend to hang out on streets, and you are therefore more likely to see them if you follow a route along those streets. Routes are an efficient way of covering quite a wide area, so you can capture a lot of variation in animal density, and we all know how much roaming dogs and cats tend to cluster, with known hotspots and conversely deserts for roaming animals. I've also found routes more satisfying to survey the polygons because they allow for a more efficient movement. Now, I've created quite an extreme example here of a polygon, but you can see how surveying this polygon requires observers to double back on themselves and cross their own paths, as compared to a route which can be designed without having to cross your own path or double back. I'd now like to describe two broad options for routes that I've used, unbiased and hotspot routes. So firstly, unbiased. This means a route that is unbiased with regards to animal density. It was designed making no attempt to capture or avoid roaming animals. They are representative with regards to road types and land use. So they try to capture main roads and minor streets, industrial areas and residential areas in approximately the same proportions as seen for the whole area. Here is an example from Panama City, where I worked with Spay Panama on a dog survey. I designed 4 routes before I arrived, so I had no idea where we were likely to find dogs, and they were hence inherently unbiased. I tried to capture all the different road sizes and land uses I could see from Google Earth, trying to match their proportions within the routes, so that these could then be used to represent the wider city. Surveys on unbiased routes result in data that can be used to estimate the average number of dogs or cats per kilometre of street across the area. You can then multiply that average density with the total street length within that area, and that provides you with an estimate of the total roaming dogs or cats at the time of the survey, an important qualifier that I want to talk more about. So here is an example from Kathmandu, where HSI conducted a survey with the local NGO Manamitra, who then implemented an intervention. The red boundaries show the 14 wards. The purple line is the survey route that wound its way through these wards. The average dogs per kilometre was counted to be 12.3, taking the total street length of 26.1 kilometres. This provided an estimate of 1,551 dogs on the streets of this particular area between the hours of 6 and 8 in the morning when the survey was conducted. So, was this the total roaming dog population? No. And that's because of the issue of detectability or incomplete detection. This is the proportion of the total roaming animal population that was actually seen and recorded by the observers. So why did they miss some? Well, some will have been hidden from view, which is much more likely with cats than dogs, and others may not have been roaming at that time, but do roam at other times. And this is likely to happen with animals that are owned, but also allowed to roam. So the question is, how do we measure detectability? This is commonly done using mark resite techniques, where you mark and release a known number of animals and then see how many of them you see again on your subsequent resite surveys, or a version of that approach using photos to individually identify animals and then create a recapture history for each individual. I've given just 3 examples here of mark resite approaches using paint, using photography, and using marks applied during an intervention. When I've done with this presentation, I'll put these references into the chat so you can take a look at these if they interest you. Going back to our Kathmandu example, an estimated average detectability of 0.44 was used. This estimate came from a mark resite survey of a sample of 6 wards across the city, using paint sprays to mark as many dogs as possible within the ward, keeping away from ward boundaries to avoid emigration of marked dogs, followed by an exhaustive search of all the streets within the ward the following morning to resite marked dogs. So, taking that original estimate of 1,551 dogs, we divide that by the estimated detectability and we get a corrected estimate of 3,525 dogs. Estimates of detectability are relatively rare because they are time consuming to do. The ones that I know of for dogs fell between sort of 0.3 to 0.5. I'm afraid I don't have a range for cats, but I know that detectability is lower in general for cats. So now for the alternative, and full disclosure, my favourite approach, which is the hotspot route. So this is biased towards roaming dogs and cats. It's been designed to be the most efficient way to cover as many known hotspots for roaming animals as possible within your available survey time. Here is an example from Cernavodă in Romania, where Save the Dogs and Other Animals run a survey every quarter along a single hotspot route. This route focuses on known hotspots for roaming dogs, which tend to be on the outskirts of this particular town, avoiding those inner town areas that would be a waste of time to survey, as the streets are likely to have comparatively few dogs. The idea is that this survey will be extra sensitive to changes in the dog population in return for relatively little survey effort. What you're doing here is measuring a population index or indicator, which should reflect how the wider population is changing. One important point is that if you take the average dogs per kilometre from this route and multiply it by the total street length, you're likely to get an overestimate of the population size, and the extent of that overestimate will be unknown. So in summary, we have 2 route types. We have unbiased with regards to where the animals are and roughly representative. Using the average density, you can extrapolate by total street length and by detectability to get a population estimate. But know that unbiased routes can actually be quite dull to survey because your roaming dogs and cats are not evenly distributed, they cluster, and it's likely that your unbiased route will cover some areas with very few animals, and you can probably guess before you start where that will be. And then we have hotspot routes. They focus on where you are likely to find roaming animals, which means they are an efficient way to survey a larger proportion of the roaming animals and therefore can be a more sensitive index of the population for your available survey effort. They can't be used for estimates, so they are best for monitoring changes over time. Now I'm going to do something that appears perhaps unusual for someone who's done a lot of surveying. I'm going to start to question whether calculating a population estimate, that is an estimate of the total number of roaming dogs or cats, is worth your effort. So, knowing the total number of roaming dogs and cats should tell you the size of the unowned dog or cat population. Well, no, it doesn't do that, because an unknown proportion of roaming dogs and cats will be owned. You can't assume they're all unowned. In fact, in most countries, the majority will be owned roaming, especially for dogs. The total number should tell you how many sterilizations you need to do. Well, also no, because confined dogs and cats, not included in your estimate, can also be a source of the next generation of roaming animals, as their breeding may also be unwanted, so they are also a valid target for sterilisation services. There will also be immigration from surrounding areas and turnover, with both sterilised and unsterilised animals dying and new unsterilised animals being born all the time. So your estimate is only for the number of animals on that day. Look over a year and the number potentially needing to be sterilised is far higher. The number of roaming dogs or cats allows you to predict how the population will respond to sterilisation and other interventions. Well, it helps, but without measures of survival and breeding of the different subpopulations and how animals move between subpopulations, it's not possible to make robust predictions. And finally, producing these estimates and calculating detectability does take a lot of effort and time, which tends to be something that we're short of. So I'd like to make a suggestion for how to approach surveys, and this is from the perspective of resource limitation. If you have the time to invest in more intense surveying, then that is absolutely great. Please don't hold back if you have that capacity. But if not, then here's my suggestion. Use an unbiased route to get your average roaming dogs or cats, and then multiply this up by total street length to get your estimate of roaming animals at the time of the survey. If you survey at peak roaming time, which is usually at dawn, you can also describe this as the maximum number of dogs and cats roaming at any one time. Know and state that this is an underestimate, and the extent of the underestimate will be greater for cats because detectability is likely lower than for dogs. You know you have at least this many roaming dogs or cats. Now, this should be enough to create a rough budget and get started with an intervention. And this is where your time-efficient hotspot route comes in. Get a baseline before the intervention starts and then monitor regularly, at least once per year, but preferably more frequently, particularly in the beginning, all along the same hotspot route. Your unbiased route can then just be put on the shelf. You don't need to survey it again because it is the index of the population from your hotspot route that will tell you how your population is changing. And then use this data to evaluate your intervention coverage and impact on density and welfare and whatever else you care about, and adaptively manage, which means spotting successes and failures and changing your intervention for greater impact. I have one more suggestion to make. If you are visibly marking as part of your intervention, so collars or paint for vaccination, or ear notches, tips or tags for sterilisation, you can do an opportunistic mark resite study to calculate detectability, and then go back and adjust your original estimate. So firstly, you need to record all the marked animals you release within a known area, excluding any animals that you know are confined. And then you need to be ready to do your resite survey, and this needs to be done quite soon before mortality or mark loss starts to impact on the number of marked animals out on the street. And your resite survey needs to be exhaustive, which means you are searching every street for roaming animals within the release area, plus a buffer zone around that release area that allows you to feel confident that your marked animals haven't left. Because this study assumes that your population is closed, so no marked animals are leaving. So do think about this resite survey first. How big an area can you realistically survey? And can you ensure your marked animals are still within that area? Natural boundaries like rivers and coasts and so on may help you here. Your detectability estimate is then very simple. It's the number of marked animals you see on the resite survey divided by the total number of marked animals you released into the area. So then you can go back to your unbiased route estimate, divide that by your newly found detectability, and get an updated estimate of the total roaming dogs or cats. Now, this is an opportunistic, convenient mark resite study. but it's not especially robust. This analysis is subject to a number of assumptions that may not hold true. So it's a useful step, but know that there's likely still some error in this estimate. And it is your ongoing monitoring that will tell you whether the intervention is working or not. Excuse my cat while he reorganizes himself. Okay, so now on to analysis. Again, this is a huge subject area, which I cannot cover in any depth today. And I can recommend again, the introduction to data analysis available from the DC Cat Count group as a good overview. So I just want to share some key points for how to approach analysis. First, it may sound obvious, but you need to go back to your impacts and your indicators and really focus on what is meaningful for you and your intervention. Surveys always throw up plenty of interesting data, so you really need to hone in on what matters. And second, I always start with visualization of that data you identified as meaningful. So this is one of my favorite examples of survey data from Helping Suffering in Jaipur, India. I like it because of its simplicity, and it also shows their long-term dedication to data collection. So they use 6 routes, which they walk every 6 to 12 months. And what you see on the graph is simply the total number of dogs seen on those 6 routes. And you can see the clear decline in that number over time. Here is a similar example from Spain, Panama, but this time the data is the number of dogs per kilometre of street surveyed on 4 different routes over time. You can see here the difference in density between the different routes and also the steady decline in density over time. Here is an example from Manamitra in Kathmandu, and this shows the change over time in the percentage of lactating females that are, females that are lactating on 3 routes that had benefited from their intervention. Now, I also want to flag something important about this data set that really helps data robustness and ability to measure change over time, and that is replication. So you can see here, there are 2 data points on each time point. And this is because the survey was done twice on 2 consecutive days. If I flick back 1 slide, you can see the same here. 2 surveys and the same point of time for each route. Now, this replication provides a measure of how your indicator changes on a day-by-day basis, giving you something to compare to changes you see over months or years. This can really help your statistical analysis because you know what level of variation is down to daily fluctuations in measurement, and therefore what variation seems to be down to real changes in population over time. So if possible, do try to find time to repeat surveys on successive days, even if you only have time to do that twice. More is always better. Just to say, don't feel restrained by the scatter graphs I've showed you today. You can use bar charts to show changes in indicators over time, like we have here for the percentage of lactating females in Bangkok over 3 survey events. And here is a box and whisker chart that shows how dog density has changed over time. There are some visualizations that suit some data types better, but it's also up to you to select which visualization means most to you. This graph shows us something different. This is the changing dog density over time. At this point, we only have 2 survey events on 20 different survey routes. And Dr. Ob from Soy Dog will be telling you more about this data and the 3rd survey they have now completed a bit later. But what is different is that 18 of the routes in orange are routes that cross areas where CNVR has been done. But the 2 routes in blue cross areas that have not yet been reached by the CNVR effort. So as far as our hypothesis goes, that CNVR will reduce dog density, the 18 orange routes are treatments and the 2 blue routes are controls. Although the reduction in density is not steep on all treatment routes, they do on average decline. While the 2 blue routes show an increase, what this does allow you to do is test that hypothesis that it is your intervention that has caused the decline. Now we have a very small control group here. So again, this is not the perfect study design, but we may do with what we had. The key point is that control groups are a fantastic contribution to your data. If you can include surveys in areas where you're not working, you can compare your indicators in areas where you are working to areas where you don't, and develop a much more robust data set to measure your impact and claim attribution for this impact to your intervention. This is again some data from the Soy Dog CNVR project in Bangkok, and this is an example of comparing the extent of intervention effort against the change in an important indicator. So each dot represents one of the 20 survey routes. We are now at the point in the project where all areas have received CNVR intervention, but the extent of that intervention differs. So here the measure is the proportion of female spays in the CNVR numbers. And we can see that the more females that make up the sterilisation effort, the greater the percentage decline in dog density when we look over the full 5-year period of the project. So to summarise, just visualising your data is a form of analysis. This can help you see how measures of important indicators are changing over time and allows comparisons between areas that may differ in how much intervention they have received. There are ways you can increase the quality or robustness of your data. I've mentioned replication and control groups today, but there are other important issues. These are covered in more detail in the chapter Making Your Impact Assessment Robust, which is part of ICAM's Are We Making a Difference guide. This includes the important issue of maintaining consistent survey protocols throughout, so that your data can be compared over time and between location. A final word now on statistics. This is the part of analysis where you look at the changes in your data and ask whether these changes are real and meaningful. Or could you have found these changes just by chance? And further, you can look into whether you can predict why your data has changed in this way. A summary of statistics is way beyond the scope of this webinar, because which statistical test or model to use will depend on many characteristics of your data, the way it was collected, and your indicators. You will need the help from someone with training in statistics for this step, but that help will benefit hugely from you being able to explain which indicators you really care about, and also sharing your visualizations of data and pointing out those patterns that you think are interesting, and also really good data on your intervention effort, when, where, and how many animals or people were involved in the intervention. Okay. So that is now the end of my presentation. If you have any questions, please add them to the Q&A function and I'll do my best to answer them in our final session. I'm now going to start the next presentation, which is from Joe Lieberzeit on the cat survey in the US. Give me a second to start up that video.